Welcome to The Explainer. Today, we're diving straight into the absolute cutting-edge mechanics of automated market makers, and more importantly, the hidden systemic risks that come with them. We tend to think of decentralized finance as this pristine, perfectly engineered landscape, right? But when you start pushing the mathematics to their absolute limits to achieve unprecedented scale, well, things get incredibly fascinating and, honestly, a bit dangerous.
I mean, just think about this massive, incredibly ambitious question visionary developers are trying to answer right now. How do you build a liquidity pool for 10,000 stablecoins at once? We're facing a future with millions of digital assets. Imagine a single pool where thousands of different stablecoins can be swapped seamlessly, without splitting all that capital into a million tiny, fragmented pairs. It sounds completely impossible, but top-tier architects are actively building the mathematical foundations to pull off exactly this kind of scale.
So to wrap our heads around how they're actually doing this, we've got to look at the n-dimensional AMM. This is a structure that moves completely beyond your simple pairs of tokens. Historically, we just had isolated pairs, like USDC to USDT. But an n-dimensional automated market maker allows liquidity provision across 3, 4, or even dozens of assets simultaneously, all within one unified pool. It manages pricing and reserves by using high-dimensional geometric invariance. So think of complex mathematical shapes like massive multidimensional spheres or donuts called toroids. The AMM calculates trades by basically moving along the surface of these shapes to keep the entire ecosystem perfectly balanced. Here's our roadmap for today. We'll hit the n-dimensional AMM vision, swapping via polar coordinates, multi-coin fragility, divergence loss, and SVB, and finally, hedging depeg risks. Let's get right into it. Part 1. The n-dimensional AMM vision, from circles to toroidal dimensions.
Think about how much these systems have evolved. We've gone from totally capital-inefficient models to highly concentrated, multi-dimensional shapes. In the early days, AMMs just spread liquidity uniformly across an infinite price spectrum. That meant the vast majority of your capital just sat there, totally idle. Then, Uniswap v3 came along and let users restrict their active assets to finite price ranges, heavily concentrating that liquidity exactly where the trading actually happens. And now, concepts like the orbital AMM are taking that exact concentration and projecting it into higher dimensions. Instead of a flat line, a price tick becomes an n-dimensional spherical cap. The liquidity is dynamically orbiting around an equal price point.
Moving to part 2, swapping via polar coordinates, the trigonometric trick. Now, plotting these massive dimensions mathematically is a total nightmare, which brings us to a brilliant workaround. Traditional AMMs use standard Cartesian math, moving along a rigid x and y curve. But Cartesian math involves heavy division and square root calculations on chain. It's notoriously expensive and totally prone to rounding errors. Polar AMMs take a totally different approach. Systems like OrbSwap essentially treat the pool as a circle. They calculate trades by rotating around a focal point using polar coordinates and trigonometric angles. So converting one token to another isn't an algebraic headache anymore. It's simply treated as rotating an angle. Take a look at that super elliptical shape right there, which beautifully concentrates the capital density. And check out those wrapped polar ticks. In a stablecoin pool where everything is perfectly priced at $1, the perfectly neutral polar tick sits exactly at a 45-degree angle. Every subsequent price movement, it's just measured as an angular deviation from that center. It is incredibly elegant. And this perfectly illustrates why you'd want to escape the limits of Cartesian designs. Look at the difference when comparing traditional models with polar AMMs like Lens. By leveraging something called the Brahmagupta group product, which is basically just a highly efficient mathematical shortcut, these systems actually achieve O of 1 constant time execution. They can handle multi-asset swaps using just basic addition and multiplication matrix updates, no heavy on-chain division, no square root drifting. It is literally just instant and efficient. Which brings us to part 3, and honestly, the absolute crux of our deep dive today: multi-coin fragility, the Icarus flight of DeFi. This is exactly where the beautiful, flawless mathematics crush headfirst into the messy reality of human markets. This quote from the research hits the nail on the head. When you have 2 tokens, the risk is contained. But when you start extending these pools to 3, 4, or dozens of stablecoins, what we call n greater than 2 pools, you are actively building in massive systemic fragility. We assume stablecoins are, well, stable. But historically, their price drops are extreme and sudden. That's fat-tailed behavior. Stacking these multidimensional pools inherently scales that fragility, creating this intricate house of cards where just one asset failing can take down the rest. Just look at the asymmetric skew in this USDC to USDT pool data. Stablecoins aren't perfectly stable. They show massive asymmetric skews and heavy negative tails that the pure math simply does not expect. The math assumes a normal, symmetric distribution around a peg, but human behavior, panic, redemption fees, they completely warp those perfect geometric shapes into sharp, violent downward spikes. Part 4. Divergence loss and SVB. When the peg breaks. To truly grasp how dangerous this is, we have to look at a historical black swan event. Let's walk through the 2023 Silicon Valley Bank collapse. When news of the bank's distress hit, USDC, which was widely considered one of the safest assets in crypto, violently depegged. It plunged to 85 cents on the dollar. Instantly, traders panicked and fled, dumping their USDC into the perceived safety of USDT. Now, if you're a liquidity provider in one of these multi-coin pools, the automated math doesn't understand panic. It blindly follows the curve. So, as the market dumps USDC, the AMM forces you, the liquidity provider, to be the buyer of last resort. You accumulate the plummeting asset while the pool gets drained of all the valuable USDT. These supposedly correlated assets actually anti-correlated in a panic. So here is the terrifying reality. During a true bank run, your high-dimensional mathematical marvel just forces you to buy the plunging asset all the way to the bottom. In an n greater than 2 pool, the entire structure acts as a trap. If just one of those assets suffers a permanent depeg, the liquidity provider suffers catastrophic divergence loss. The more assets you stack into this high-dimensional polygeometry, the more exposed you are. A single point of failure can drag the entire pool's capital down to zero. You're literally scaling your systemic risk with every single coin you add. Finally, Part 5. Hedging depeg risks, the mathematical life raft, because you definitely need one. So, how do we survive this? Well, researchers have proposed an ingenious way to use the AMM's own internal logic against itself. This setup essentially builds a synthetic binary prediction market directly inside Orbiswap. If you're going to risk providing liquidity in these fragile multi-coin pools, you absolutely must hedge. By executing a precise vertical spread with your polar ticks, you can actually build insurance. It works like this. You find an unused tick way out of the normal trading range, say 1 degree out from the peg. You build a long position there. Then you borrow, unwrap, and short a second LP position immediately below it. Combine them, and you've got a vertical spread. If the stablecoin permanently depegs and crashes right through that tick, your synthetic option pays out. It gives you a guaranteed payout to cover that massive divergence loss destroying your main position. It's a brilliant mathematical life raft built entirely out of the protocol's own existing blocks. And that leaves us with a pretty massive question to ponder. As we keep building these ever larger digital architectures, can pristine mathematical truth ever truly tame the messy, probabilistic chaos of human market panic? We can invent n-dimensional super ellipses, and we can rotate them through polar coordinates with perfect algorithmic grace. But at the end of the day, these flawless mathematical systems still have to survive the very real, fat-tailed chaos of a human bank run. Thanks for joining me on The Explainer today. Keep questioning the systems around you, and I'll catch you next time.